Hello again, everybody. In this video, we're looking at some more of these angles within a circle. These two formulas we're going to unpack are much less frequently tested on the SOL, so it's lower down on the priority list, but I thought we'd walk through a couple examples of each. The first formula we need to understand is the angles that intersect on the the lines that intersect on the interior of a circle, creating interior angles. So let's say I want to find this angle that's marked here. I'll call it X. There's a special formula that goes with this situation. The interior angle, is equal to the sum of its arcs. So here, this angle would go with arc AB. That's one of the intercepted arcs. And we know that vertical angles are congruent, and this angle intercepts at CD. So those are the two arcs I'm talking about. And it's half of that sum. So the sum divided by 2. So our interior angle, where we put X, is equal to the sum of the two parts divided by 2. Okay? All right, so let's work out some practice problems with that one. Come straight down here. All right. Well, here it says find angle YWX. YWX, talking about this pink angle I've marked here. If you look at the picture, the arcs that are given to me don't match up with YWX. The 43-degree arc and the 81-degree arc match up with these interior angles. So if I use the formula set before me here, I'll be able to find the blue angles, and then I can work to finding the angle that it's asking for. So my pattern is that the interior angle is equal to half of the sum. So what I need to do is, I'm going to call this one X. X, the angle, is equal to the sum of the two arcs divided by 2. The sum of the two arcs divided by 2. All right. Order of operations says add the numerators together, whatever's in the numerator first. So I've got 43 and 83. That makes 126. Then divide that by 2. We're going to have a 63-degree angle. So this angle in blue is 63 degrees. But the question is asking me to find the measure of a YWX, so I need to find the pink angle. So if you notice, these two angles, cover the rest of this up, these two angles make a linear pair, and linear pairs have a sum of 180 degrees. So to find the measure of angle YWX, I need to take 180 degrees and subtract the angle that we found. I'm going to get 117 degrees, which looks much more probable for this picture, considering that's an obtuse angle. Okay, let's try the next one here. Our goal is to find the measure of the arc C to D to E. Find the measure of arc C, D, E. Okay, so if you're looking at the formula above there, notice that the arc is going to be on the right side of the equation. So our X, our unknown amount, is going to be over here somewhere. All right. Well, this time the angle that's given to me is 128 degrees, and that angle intercepts arc CDE. that 128 degrees would have a partner in the vertical position, and that would go with arc 73 out here, this 73-degree arc. So all the parts of what I need are highlighted in blue. Let's put together this formula. The angle that's 128 degrees is equal to the sum of the two arcs. Now I know one of the arcs is 73 degrees, and I'm trying to find the measure of the second arc divided by 2. So now I got to figure out how to solve for this x. Algebraically, my choice is going to be to get rid of this division of 2. To get rid of a divide by 2, we need to multiply by 2. I'm going to multiply both sides of the equation by 2. 128 times 2 is 256. The fraction is gone, and now I need to remove the 73. This is a positive 73 that's added to the x, so I need to subtract it. I've got 183 is equal to the x value. So that means the measure of arc CDE is equal to 183 degrees. Okay, so when you have an angle in the interior of the circle, when it's on the interior of the circle, the formula is the half of the sum of the arcs equals the angle. Sometimes we write it out very basically in my class. The angle is equal to arc plus arc divided by 2. If you want to keep it very basic, okay? All right, our next walkthrough is going to be about intersecting secants on the exterior. Notice that the point of intersection is outside of the circle, okay? Therefore, the exterior angle, okay, it's also very similar to this formula we just walked through, but this time it's going to be the larger intercepted arc, so the measure of DE, subtract the smaller intercepted arc, the measure of BC, all over 2. So look, it's very similar to what we just put together for the interior angle, and I think that's why this is so confusing. The exterior angle says find the two arcs that are intercepted. In this case, it's DE and BC. In order to keep it positive, we want to do the larger arc, subtract the smaller arc. If you flip these around, you're going to get a negative angle measure. And then take half of that. If you want to write it out more generically, you could say that the angle is equal to the large arc minus the small arc divided by 2. Try to keep your formulas super basic. All right, let's do some practice down here. All right, we are asked to find angle BCD. Angle BCD is out here. Looks very tiny, but remember, you can extend those rays if you need help finding the arcs that go with the angle. So the arcs that go with this angle are going to be the two inside pieces, AE and BD. All right, now the formula says the angle is equal to the large arc minus the small arc divided by 2. So the angle is what I'm trying to find. That's equal to the large arc, which is 67, minus the small arc, which is, I don't know it. So put a freeze on that formula. We're going to have to do a little bit of circle work here. It looks like this circle has been intersected down the diameter. We've got a little arc measure of 67, another arc measure of 94, an unknown arc measure that I'm trying to find, and it looks like this is an unknown amount out here, But we know that a diameter cuts a circle into a semicircle, cutting it in half. So this is a 180-degree arc that's unmarked up here. So in order to find this little arc, all I have to do is subtract each of these from the full circle. So a circle has 360 degrees, and if we subtract each part away, what's left will be that small arc. 360 minus 180 minus 67 minus 94 leaves me with just 19 degrees for this small arc BD. So I can put the 19 degrees into my formula to finish out the problem. Large arc minus small arc divided by 2 equals the angle. 67 minus 19 is 48, and 48 divided by 2 is 24. So the measure of angle BCD is 24 degrees. Okay, that was a great review of a lot of circle-y things. We had to find that missing arc in order to put into the angle, and then we had to fill out the formula properly. Let's try one more here, our very last example. Okay, we've got that exterior angle out there. So I know I'm using this formula, the large arc minus the small arc divided by 2 equals the angle. However, in this problem, I'm asked to find arc SW, the measure of arc SW. Okay, so looking at the formula, look at where your X is going to go. This is certainly the large arc. And the large arc's position is here, on the right side of the equation in the top of the fraction. So let's piece this together. The exterior angle is 40. The large arc is what's unknown. The small arc that goes with this set is the 75, the other intercepted arc. Over 2. So I know my answer has to be greater than 75 if it's going to be the large arc. All right, so now we got to put our algebra skills to use. I need to get this x all by itself, which means I need to get rid of the division of 2. I'm going to multiply by 2 to get rid of the divide by 2. Those are inverses of each other. 40 times 2 is 80. Now I need to get rid of a subtract 75, so I'll add 75. 80 plus 75 is 155. So we've just found the measure of arc SW, 155 degrees. Okay, thank you for watching this video. I hope it helped out with some of these more obscure angle measures within circles. Our next video will be about the segment measures of circles. Thank you.